To get the full course, visit www.zeedup.com. Hello everyone, welcome back to the Linux tutorials. These tutorials are brought to you by Zeedup Technologies and Services. In this video, we are going to start with the shell scripting. So first of all, we know that what is a shell, right? Shell is just like a translator between the applications and the kernel of the operating system. It itself is a part of the operating system. And if we are talking about Linux, then there are a variety of shells available. The current versions of Linux are working with the GNU Bourne Again shell, that is the bash shell. Okay, so this Ubuntu version or this Ubuntu distribution of Linux that we have installed is also having the bash shell. So what are these shell scripts? The basic concept is that a shell script is a list of commands or a bunch of commands that are listed in the order of their execution. That is, the commands, there are multiple commands that could be written one after the other, and you would be able to execute them all together using the shell script. Okay, so this is what a shell script is. There are a bunch of things that you must remember if you are trying to write a shell script. The first thing is that a shell script is just like a file, but it's different from a regular file. How? Because a shell script is always having an extension of .sh, which means that is the shell script. Whenever we use this .sh extension, Linux knows that okay, now we are trying to use this shell script. So after this, there are also some things that you need to specify in a shell script. So we will see when we are creating a shell script. So first of all, before creation of a shell script, what I'm going to do is I'm going to make another directory or a folder that is going to hold all my shell script files. So the name of my folder is going to be shell script, and then I'm going to go inside this folder shell script, right? Now if I use my pwd command, that is my present working directory, so I'm able to see that currently I'm in my home directory's document folder, and in the document folder I am inside this shell script, right? Now what you can do is let us just create a sample script. So we know that in order to create a file, what we can do is we can simply use a cat command, or we can use the vi editor. So first of all, we will see that how can we create a shell script using the cat command, right? So we can simply write cat, put this output redirection operator, and the name of the file. Okay, so it's going to be like test file and .sh because it is a shell script, so we need to specify this .sh. Then press enter. Here we know we are supposed to provide the contents of our shell script, that is test.sh file. So what are these contents going to hold? These contents are going to, first of all, by convention, hold the shebang. Now what is this shebang construct? It is written like this. First of all, you need to provide this hash symbol and then this exclamation mark. This shebang is actually used to tell that the Linux system must expect a shell script after this particular line. So this is why the shell, this shebang is used. Then after writing this exclamation mark, the hash symbol, you need to specify this path of the shell, that is in the bin directory or the bin folder of the root directory. You are going to expect this bash shell. Now bash, since is our shell, so that is where we need to specify this, and then you can press enter, and now you can begin to write the shell script. So shell script is basically going to hold a bunch of Linux commands that we have already learned. So a simple one is a pwd, that is for the present working directory. You can simply write it, that is pwd. Okay, then what you can do is you can put a space, and with the help of this hash you can add comments. Now what are these comments? These comments actually tell roughly that what this command do, And whenever you are writing a shell script, whenever you are trying to write a good shell script, then it must have the comments, because you know what the command is used for, you know what your code or your shell script is supposed to do. But there are a bunch of other people who may read your script. They might not know actually just by looking at your script that what it is supposed to do. So with the help of the comments, you are able to give them a message that this is what this script is supposed to do, and on the basis of that, they can expect some kind of an output. So a simple comment would be that it is used to print the path. Okay, that is a simple comment that I have written. This print the path would not be understood by the Linux. Why? Because it is a comment. That's why we have proceeded with this hash symbol. So it would have like no value. It is just used for the reading purposes. Okay. Then you can provide a bunch of other commands, like you can provide the ls command. You can give its description as well, or its comment that list the files. Then you can use other commands as well, like you can use this any command that you think is good for yourself, you can just use it. Okay, so you need to specify these bunch of commands. So just give me 2 minutes and I will come back with all these commands written over here. Okay, so now I have written these bunch of commands. I can just press Ctrl D from my keyboard. And if you want, you can just check the contents of this test.sh file once again. So all of these are the contents. Okay. Now how can you execute it? Now this is where the third permission of our set of permissions, that is read, write and execute, is being used. That is, we need to execute these shell scripts. So we need to have the execute permission for executing them, right? So how can we see the permissions? We know that using this lsl command, that is the long listing format, for a particular file, we can just see its permissions. So you can see we as a user or the owner of the file, we have only the read write permission and we do not have the execute permission. So what do we need to do is we need to provide the execute permission by using this chmod. So user, U is for user, I'm going to use the symbolic mode, and I want to just add this execute permission. So I've used this plus symbol and X for execute. Then you can specify the name of the file for which you want execute permission. So my file name is test.sh. Now if you just cross check it, so the user or the owner is now having this execute permission as well. Now what can I do is I can execute this file. So the question is, how can you execute a this shell script? For this purpose, what you need to do is you need to write a Linux command, and that Linux command is a very simple one. You can simply write sh, put a space, and then the name of your file, that is test.sh. Now you can see a bunch of things have happened. Actually, if you would have seen it, then all these commands would were executed one by one. Okay, so the last command we had was a manual page, which is in front of us right now. If you just press Q to quit it, you can see we are getting the output of all of them. First is the present working directory, so we are getting the present working directory. Then we are getting ls, that is a list of files. So since in this shell script folder only this test.sh was present, that is why only this file is being listed. Now we use this process listing or this ps command. Then you can see that since the shell script was being executed, so we are also getting this sh process as the running process, right? And then we are getting these three processes that are currently running. Then I used this manual command to just bring up the manual page for the ls command, which was present in front of us, which we quitted by using the Q letter from our keyboard. And then the last one is the username by using this whoami command. So my username, that is virtual, is present over here. So this is how the bunch of Linux commands could be executed using the shell script. Now there are other things also we can use the shell script for. but the basic purpose is for executing the Linux commands. So up till now you have learned much more, you have learned a lot of Linux commands. I want you all to just practice them all with the help of the shell scripts and try to just see whether they are working for you or not. From the next video onwards, we will take a look at some more examples or some more ways through which these shell scripts could be used. In this video, we are going to focus about the processes in Linux. So if you remember, in a video we discussed about the different processes and how can we just work with them, how can we find out with the help of the ps command that what processes are running into our system right now. So if we just use this ps command once again, we will find that these two processes are running right now. Okay, so the reason why we are seeing it in the shell script tutorials as well, it is because while working with the shell script tutorials, we can encounter stuff where we have to just work with the processes and we need to understand that how can we prioritize them. So here is the command, that is this psl command. If you just execute it, you will see this is something called ni. So this ni is actually the nice value of the process. You can just set the nice value to change the priority of a particular process. Okay, so how can you just change this nice value? How can you reassign a new priority to the process? It is something we are going to see in this video. So a very simple example of how you can do is using a command that is known as the renice command. Now what is this renice command? This renice command helps you to reassign the nice value of a particular process. To refer to the particular process, you need to know its process ID. So here we know the process ID of this bash process, that is 5989. And we can use this process ID to reassign the nice value. Right now its nice value is 0, but we can assign it any number from, be it a negative number or be it a positive number, from -20 to 20, I think. That is what we can assign. So let's see that how can we work with it. So since we are working with processes, so it is something that is or this work is assigned to a super user. So to work with the processes, to work with its priorities, we need to use the sudo command. That means we need to refer to the super user. Then we can simply use this renice value. And then with the end switch, we can specify the new priority. This end switch helps us to specify the priority. Suppose I'm changing the priority to 10. Okay. And then I can specify the process ID, that is which process's nice value I want to change. So I can just use this p switch, which will help me to specify the process ID. Process ID in my case is 5989. And I press enter. So it asks me to enter the password of my super user. So let us just enter that password. And you can see now we are getting a message that with this process ID, the old priority was 0 and now the new priority is 10 because we specified this 10. Okay. Now if you want to cross check it, you can again use this psl command. Then you can see the bash process with this process ID 5989 is having a nice value of 10. But along with this, the next process that we are having, that is this ps process, is also having a nice value of 10. Why is that? It is so because if you look closely at the process ID over here, so the bash process has a process ID of 5989 and you can see the ps process has the parent process ID. This is the parent process ID. So the parent process ID for ps is also 5989, which means that ps process is the child process of bash process, or in other words, bash is the parent process for ps. Now if you change the priority of the parent process, then the priority of the child process changes automatically. And that is what we are seeing over here. As soon as we changed the priority of the ps process, that is the child process, changed as well. Now this is how you can assign a positive priority. Suppose you want to assign a negative priority. then how can you do that? You can specify like -10 here, and again the old priority was 10 and now the new priority is -10. Now it didn't ask us for a password because it already knew that we provided the password, so we are authorized to do that. Okay, again if you use this PSL command, then now the nice value is -10. If you want, you can reassign the nice value to 0, which is the default one that we had earlier. Then you can see the new priority is now assigned to 0 and PSL, now the nice value is 0 for both the processes. So that's how you can just work with the nice values. That's how you can just work with the processes in Linux. Now it is going to be holding utmost importance whenever we are working with the shell scripts. Thus it is mandatory for you to understand that what you should do, how can you just reassign the priorities, right? Now the question is, we have reassigned the priority or we have changed the nice value. How we can just check the nice value of a process? So what we can do, right now we know that the terminal is being opened, so we can just type this command to get the terminal process. Okay, now what happens, this 0 that is we are getting is a nice value, that is this terminal, GNOME terminal, it's having a nice value of 0. So how can you set the priority of a process? We were reassigning the nice value, now we want to set the nice value. So how can we do that? So we can simply write nice command, this 10. This means that the value, the nice value that we are going to assign is 10, not -10. This 10 is just acting like a switch. Okay, so this is a hyphen, not a minus symbol, that you must note. Then you need to specify the name of the process, so that's GNOME terminal. And you can just see that now 2 terminals are opened. If I just go to it, then you can see 2 windows are opened. This is a new terminal that's been opened. Now its priority is changed. Okay, you can see it is having different processes. This is the process ID 6046 and this is a new terminal window that was opened. This is the original terminal window. So the terminal window over there, it had the priority of 10, the nice value of 10. So that's how you can just assign the nice value. So this is all that you need to know about the processes. Now, since we know that shell is a scripting language, so let's see that what is the difference between a scripting language and a programming language. So, what is a scripting language? A scripting language is just like a programming language, but the difference is that the scripting languages are interpreted while the programming languages are compiled. What do you mean by compilation and interpretation? Well, whatever code we write, it is written in our own language, preferably English or some of the syntax of the programming language in which we are coding, right? Now this language is not understood by the computer or the kernel, so the shell just translates these programs into the language that is understood by the kernel, right? Now this translation can take place in 2 ways, the compiler and by the interpreter. What does the compiler do? It just takes the whole program and translates it in one go, and whatever the output is or whatever the errors are, they all are displayed in one go. While the terminal does the same process of translation in a line-by-line fashion. It scans one line and sees that okay, there is some kind of an error, and it shows us that error and halts while we are trying to solve that error. So until and unless we have solved one error, we cannot move to the next line with the terminal. That is why a terminal is termed slow while a compiler is termed fast. But nowadays we know that the computing power is increasing day by day, it is getting better day by day. So the difference between the compiler and the interpreter has been removed to an extent. Still, if you are running huge programs that require huge number of resources, then this difference is visible. So the main difference is the scripting language uses an interpreter while the programming languages use the compiler. However, it totally depends upon the environment in which they are being compiled or they are being executed. Like, for example, C, it is a compiled language. It is a programming language, so it is compiled. But we can design an interpreter that is used to just scan the C programming language in a line by line fashion and give us the output. So this is also a possibility. On the other hand, some of the scripting languages like JavaScript, for those we can design compilers and then they could be just changed into scripting languages. So basically the difference between the scripting language and programming language is not much. It is just of that how they are converted into the code that is understood by the kernel for performing the operations upon them. In this video, we are going to focus on the concept of variables in the shell scripts. So those of you who don't know what is a variable, let me tell you that variable is just like a container. It is used to hold the values. Okay, so we can create the variables in Linux using the shell scripts. There are a bunch of variables like environment variables, then we have some special type of variables, etc. So we will be seeing all about the variables in this video. Okay, so first of all, let us just create a new shell script for us and see what usage of the variables do we have. So let us just use the cat command. So var.sh is going to be the name of my shell script, and let's just use this shebang, that is bin/bash. Okay, now what you can do is, first of all, you can see that how can you create a variable. So to create a variable, you have to first define a name for it. Like, what is your variable going to be called? Suppose I specify small n to be the name of my variable. Now in this variable I can store anything that I want. Suppose I store 20, that is a simple number. Then what I can do is I can just in order to access the value of this variable, I can simply use this echo command, and I can access its value by pressing this $n. So if you want to access the value of the variable, you have to use this dollar symbol, right? Then this variable's value would be accessed. Then you can just press Control C to end this file over here. And if I just try to view the contents of this variable.sh, so these are its contents. Let us just execute it by first providing execution permissions to it, and then using this sh command, right? So you can see I'm getting 20, which is nothing but the value of this variable being printed on the screen. So this is what the echo command is used for. Now if I just try to use the vi editor on this var.sh, then I'm able to actually I just created a new file called vat.sh instead of var.sh. So what you can do is you can just use variables here also. Like, suppose we create, firstly we need to go into the insert mode. Now what I have done is I have used this n equals 30, then I have used this read only n, which means now my n variable has been changed into a read only variable, which means you can only read it, you cannot change its value. Then to counter this statement, I have used another statement, that is n equals 40. So let us just save this file, and again we need to provide the execute permission for the user, and then we need just provide this sh. Then you would be able to execute it. That there is an error, n is read only variable, which means you cannot provide a new value to it. Now once let us just go back to our vi editor and open this var.sh. Now here we know that n equals to 20 has been set, a value has been set to it. Now what happens if we just try to unset the value, that is if we want to remove this 20 value from variable, then what we can do is we can use something that is known as unset. So we can simply use unset keyword here like this. So unset n is used. Okay, so let us just remove this echo line as well. Okay, now what happens is we have unsetted this value, and after unsetting it, if you want, we can just so now I have just printed the value of n once after providing it a value of 20. Then I've used this unset statement, unset n, to just unset the value of n, and then again I have printed this value of n. So let's see what happens by saving it. Now we do not need to provide the execute permissions again because it is already present. We just need to execute it using this sh command. So you can see we are first getting 20 because of the first echo statement, and when the second echo statement was used, we didn't get anything. Why? Because the value of the variable was unsetted, and n variable didn't had anything, so you were not able to print anything. Okay, now what do we have is we have some of the special variables in that could be used in the shell scripts. That some special variables are like this. Let us just use a new file, that is sp variables or spvar for the special variables.sh, and I'm just going to use this echo command that is going to help us use them, okay, or help us to see their applications, right? So what I'm going to do is I'm going to just use the shebang first, and then this bash. Let us just use this echo. This is a $, which is going to just print the process ID of the current shell. Okay, then we have this echo $0, which is going to print the file name of the current script. Then these two are used. Then we have like a $, with an exclamation mark, that is used to print the process number of the last background command. And then we have this $, with a question mark, that is going to present us with the exit status of the last command executed, right? So these are the four things. We can just exit this file, and we can just apply this execute permission to this file. So the name of the file is shvar, right? So this is the execute permission for the user or the owner of the file. Okay, actually it is spvar. Then we can just use sh command to execute it like this. You see, first of all, that is the process ID of the current process. Then $0 will give us the file name of the current script, which is nothing but spvar.sh. $! Would have been provided us with the process number of the last background command, since there was no background command being running at that time, so we have not got any of the process number. And the exit status of the last command that was executed. So the last command we executed in this case was this chmod, or the command to just provide the execute permission. So it exited in, or it resulted in a successful outcome. That is why we have got the exit code as 0. So this exit code 0 is being shown to us. So this is how these special variables work. We have also some other variables which are used to get the command line arguments or the command line inputs from the variables. Like when we are writing the script, then we are able to get the command line arguments for them. We are able to get the input from the user for writing our scripts. So how can we work with these kinds of scripts? This is what we are going to see in the next video, where we will see that how can we create scripts where we are accepting the input from the user, and depending on that particular input that is given, we are able to just carry out or bring the output. So it is going to be a custom output based upon the input. So that's all for this video. In this video, we learned about the variables, how can we create variables, how can we make any variable a read-only variable, and how can we just delete a variable from a value. In this video, we are going to see some more special variables that are available in Linux for us while executing these shell scripts. So in the previous video, we have already seen some of them, and we will see some more variables in this video, some more special types of variables. So let's see their usage. What I have done is I have already created a shell script for those variables. Let us just see it in the VI editor. So this is the script that I have created. First is the shebang. Then we have some of these variables here. Okay, so the first one is to just print the file name, that is $0, and we have used it with an echo command. So echo file name $0, which means we would be getting the name of the file. And you can see within the double quotes we can specify any of the message as well if we want, and then we can specify that what we want to print inside double quotes as well. So this would be printed, right? And then we have the thing like name. So what we are expecting the user to do is we want the user to just execute this particular file using this sh command, and when they are executing it, then we want them to specify or supply two arguments. The first is going to be the name of the user, and the second is going to be the designation of the user. So how can we access those arguments? We can access them by the number 1 and 2. So this number 1 is going to give us the name of the argument, and this number 2 is going to give us the designation of the user, right? So these are arguments known as the command line arguments in Linux, and we can specify 9 command line arguments, like 1 to 9. So they would be present. We could specify 9 arguments. We could give 9 arguments at a time, right? So we are expecting only 2 arguments in this case. Then we have this $*. What does this $* do? It is a special type of a variable that that gives all the arguments in double quotes. Like if you are receiving 2 arguments, in this case 1, 2, so it will just give 1, put a space, and then 2. So this is for what purpose this $* is used, and that's why I have written the message as all arguments. Then if you want to find out that how many number of arguments you have given, you can just give this $#, which is going to give us that how many number of arguments we have given to it. Okay, and then there is another way through which you can specify or access all the arguments, and that is through $*. So basically $* and both do the same task, that is of accessing all the arguments that you have provided. But since there are 2 methods to do that, so I have shown both of them. Okay, now let's just go back to our original to our terminal, and I have already given the execute permission for this particular file. So if you want to just cross check it, you can just use this lsl command, and you see the user is already having this execute permission for this file. So we need to simply execute it using this sh command. I can just press vars.sh, and then you need to specify the argument. So I need to press or give 2 arguments. So let us just take a sample name, say Daniel, and his designation is going to be a manager, right? And as I press enter, then what do I get is a file name, that is vars.sh, which is absolutely correct because vars.sh is exactly the name of my file. Then I'm getting the name as Daniel, which is nothing but the value of my first argument. So whatever value you provide in your first argument would be printed over here. right? Then we have designation, that is manager, which is the value of our second argument that we provided, manager. And you can see we can provide multiple arguments that are separated by a space. So wherever we type a space, we would be getting a message to the Linux that okay, we have split our arguments, that is space separated arguments are separate arguments, right? Then if we are talking about all arguments, so here was $@ symbol where we are getting all the arguments like Daniel and manager separated by space again. If you want to access the number of arguments, so the number of arguments is 2. And then again using $*, we are able to identify this all the arguments, which is nothing but Daniel, manager separated by spaces. Now let's see what happens if we just provide more than 2 arguments, like 3 arguments. So we can give any value like NA. Then what happens is we are able to get these 3 arguments. We are able to access only 1 and 2. But since the limit is still 9, so we are able to process these 3 arguments as well, okay, like this. But what happens if we give less than 2 arguments, if we just give 1 argument to it? Then what happens? This second thing is empty because we didn't give any value for the second argument. But that is the advantage of Linux. No matter how many arguments you give or how many arguments you are expecting, Linux never results in an error. It always generates an output. No matter this output could be wrong or it could deviate from its original purpose, but still you won't get any error, and that is the most important thing. Now suppose let us just do an experiment and try to give more than 9 values. Let's see what happens. So I'm giving the garbage values only, like 1, 2 arguments I have given, that's the third, that's the fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th. Okay. Then if I press enter, you can see we again are getting the value as 11. But this is not the correct way because there are only the 9 command line arguments that are possible. But again, if you just give it, then Linux would be able to process it. Okay, so that's the advantage of having Linux. So this is about the special variables in Linux. Now suppose we are using this again, so it doesn't matter what type of value you give to your arguments. You can give any type of value. Up till now we have been giving the string values or the letters, but if you want you can give numbers to it as well, right? As long as they are space separated, you can give anything that you want, like this. Then you can see whatever value we provided, whether it was numbers, whether it was text, or whether it was a special symbol that is asterisk, we were able to access all of them very easily with the help of these command line arguments, right? Now there is one more interesting thing, and that is how can you access or how can you print all the names? Since you can give as many command line arguments to Linux script that you want. So if you want, you need to just access all of them. Then what you can do is you can just give the numbers like $1, $2, $3 and so on, and you would be able to access all of them. So this was about the command line arguments, and let us just work with the operators in shell scripts. So we have already understood about the different types of operators when we were talking about the basic calculator. Here we will see a new command in Linux that is known as the expression command or expr command. Let's see how it works. So let's just create a new file, cal.sh, write the shebang, bin/bash, and then you can specify, suppose in a variable called value, I'm going to store the result of 3 plus 2. So how can you store the result of an arithmetic operation? What you need to do is you need to provide this symbol that is just present above your tab key. You need to provide this symbol and write this expr command, because expr command works with this symbol only. Okay. Then you need to specify the mathematical operation which you want to perform, like 3 plus 2. And then again provide the symbol to end this statement. Then you can come to the next line and use echo to just give us the value of this particular variable, which is nothing but value. Okay. Then use Control C. Okay, so now what we need to do is we need to use this chmod command to provide execute permission. Then we need to just execute this cal.sh. So now you can see that when I execute it, I'm able to get the value as 5. So why was I unable to get it before? Because this value, after this value, you do not need to provide spaces between this equal sign. Now if I just look at the current status of my file, it is like this. After value, without a space you need to provide the equal signs, and then without a space you need to provide this expressions. Then only it will work. So this is the introduction of the operators in the shell script. We will explore more about it in the next video. In the previous video, if you remember, we have discussed about the special types of variables, and also we saw that how can we evaluate the expressions using the expr command inside a shell script. So in this video, we are going to focus something more about the shell script, and basically we are going to see the different basic operators that are available for us to use in the shell scripts, and we are going to see the practical application of each and every operator. So the first operator type that we have in shell script is known as the arithmetic operators. So as we know, the arithmetic operators are used to perform the basic arithmetic operations such as addition, subtraction, multiplication, division, etc. So this is exactly for which purpose these arithmetic operators are used in shell scripts. But why are we seeing them? Because their syntax of writing is different, their evaluation is different. We have seen an example already for the plus operator, but now we are going to see the other examples as well. So if you remember, we had this file called cal.sh. If we just try to see its contents, so this was the contents in which we added this 3 and 2, and we got the value result stored in value, and this value was printed using this echo statement. Now if we just try to run this file using the sh command, then what happens is we are able to get the output as 5. So this is the usage of the plus or the addition arithmetic operator. Let us see the other arithmetic operators as well. So we will first open this file in the nano text editor. Right, now what we can do is we can just write different kinds of expressions, like for val or for anything else I want to use or show a subtraction operation. So what we can do is simply we can write expr command, and what is the numericals we can write? Simple numericals like 8 minus 5. Okay, that's a simple operation. And then I want to echo or print the value of this val variable, so that I need to do with a $sign. So this is a subtraction operation. Similarly, we have a multiplication operation. We can just write it as mul for mul. Then in this we can just write the expr value once again, like expr. Suppose if you see right now, we are having in this value we have stored 5, and in this val we have stored 3. So if I want to multiply this value and val, then how can I do that? So for this purpose, what we can do is we can just simply, instead of providing numbers, we can also write the variables, and their corresponding values, if they exist, will be multiplied with one another, right? So we can just check that by writing value. Then what you need to do is put a space and write the multiplication sign. Now this multiplication sign is asterisk, and if you remember, this asterisk is used for a variety of other purposes in the shell scripts, right? So what we can do is we can just use this slash symbol and then write this asterisk sign. So this is what you need to write. If you want to refer to the multiplication operation, then you need to write the slash sign and then the asterisk, not a simple asterisk, because then it would mean some other thing to the shell scripts. Okay. Then after writing this multiplication sign, you need to put a space and then you need to specify the second variable where its value is stored, and then we can just close this expr, and then we can simply echo the value of this variable called mul, that's mul. Okay, like this, right? Then we have the division operation. So how can we perform the division operation? Let's just write div, and you need to be very sure that whenever you're trying to write this equals sign, you need to omit the spaces, otherwise it would cause an error, as we saw in the previous video. So we can simply take examples for the division operation, like 10 divided by say 5 or anything. Then we can just echo the value of this div using a dollar symbol. Next operation we have is the modulus operation. Now what is the difference between this div and modulus? When we write this div operation, then 10 divided by 5 will give us the output as 2. Why? Because we know that the quotient is given whenever we write this div operation. Suppose we want to find out the remainder. So for that purpose, for finding out the remainder, we have the modulus operator. It is represented by the % symbol, and it is always used to return the remainder of the division operation. So let's see how can we write that. Let's just create a variable called mod, and inside this variable, using the expr command, we can simply write like 10 mod 5. This means it would return 0. Why? Because when we just divide 10 by 5, the remainder would be 0. So that is why we would be getting 0 over here. Then we can echo the value of mod. Right. Now the other operation is the assignment operation. So as we can see, this all are the assignment operators, or the assignment operation is performed over here, where we are assigning the value of this expr to this particular variable. So it is not needed to explicitly mention the assignment operator, right? Next we have the equality operator and the not equality operator, which is used to just measure the equality or inequality of a particular thing. This we will see later on when we are discussing about the conditional statements and the if or the if else or the switch statements, right? So up till now, whenever we are discussing arithmetic operators, we can just work with these 6 operators, that is these 5 that are written, and the assignment operator that is performed over here. So we have made the changes in our file. Let's press Ctrl X. They ask you to save the modified buffer. Yes, you want to save it, and then press enter. If you want to cross check whether your changes have been saved or not, you can just use this cat command. Then we can simply run our script. So you can see this is the output that we have got. Let's just cross check it. So the first thing is we are getting this value, that is 3 plus 2 5, absolutely correct. Then we are getting this val, which means 8 minus 5, which is 3, again absolutely correct. This third one, we are getting a multiplication between this value of val and val. So we have got this 5 into 3, which is 15, again absolutely correct answer. Then in the fourth value, we have got this value of this division expression, which is 10 divided by 5, which gives us 2, again absolutely correct. Then we are getting mod of 10 and 5, which means the remainder, which is 0 in this case. So all these 5 values that we have got are absolutely correct, and this helps us to understand that how the arithmetic operators work in the shell scripts. Okay. Next, we have some of the operators known as the relational operators and the logical operators. Both of them are used for the purpose of testing for particular conditions. So before working with them, we have to first understand the conditional statements, which in the case of the shell scripts is going to be the if-else statement and the switch statement. So from the next video, we will first try to learn that how these conditional statements work, then how can we write those conditional statements, and how can we work with them. So whenever we are working with some conditions, then only we would be able to use the relational operators like the greater sign or the less sign, the equality operator, etc. Then if we are required to merge more than one condition, then we have to use the operators like the AND operator, the OR operator, etc. So this all is going to be covered up in the next video lessons, but just coming up next will be the video about the conditional statements, that what is their advantage, how they work, and everything that you need to know before starting to work with the conditional statements. So this is all for this video, in which we learned about the arithmetic operators in the shell script. In this video, we are going to see the usage of the conditional statements, that is the if-else statements in shell script. Also, we are going to see the various types of relational operators and how can we write them. So first of all, if we take an example and try to understand that what is the concept behind these conditional statements. So as you can make out from the name itself, that the conditional statements means that they need a particular condition to work upon, and that is exactly the case. All the conditional statements need a particular condition on which they can work upon, and the conditional statements that we are going to see is known as the if-else statements. So if we talk about the if-else statements, they act upon one condition at a time and check that whether the provided condition is true or false. If the provided condition is true, then they perform a set of operations given to them, or if the provided condition is false, then they do or perform other set of statements, right? So that's exactly what we are going to see. They are working with the help of a very simple example. The example that we are going to take is of a number. That is, we are going to take a number and we are going to check that whether that particular number is even or odd. So in order to check whether a number is even or not, we can simply just provide a condition. That is, we can just divide the number by 2. And if we get 0 as the remainder, that means that particular number is even. And if we get 1 as a remainder, or any other number than 0 as the remainder, so we make sure that okay, this number is odd. So this is a very simple condition, and that is exactly what we are going to see in this video. So let us start with the video. I have already used this command. I have already written this command, that is, with the help of the nano text editor, I'm going to create a new file called cnl.sh. cnl is representative of conditional, and then you can press enter. Inside this, let us first write the shebang like this. Then after writing it, you need to skip for 2 to 3 lines. Then what we can do is we can take two numbers. So A, we are going to take 20, which is, we know, an even number, and in B we are going to take 13, which we know is an odd number. So these are the two numbers which we are going to check, right? An odd number and an even number. So let's see how can we write the if statement or the conditional statement to check for this particular purpose. The conditional statement is the if statement, and how can we write it? In order to write it, what we can do is we can simply just write if here, put a space, and spaces is something that you must always check off, because if you just omit some spaces or write extra spaces, then it is going to give you an error inside this shell script code. Okay. Then after writing the if statement, you need to put a single space. Then you need to write the square bracket. Then again put a single space. Now we are going to check with the a or the variable a. So what we can do is we can use the dollar symbol to write a. Then we can simply write a simple modular expression, that is a mod 2. Now what we need to do is we need to check for equality, that if a mod 2 is double equals to 0. So this is the equality operator that we were talking about in the previous video when we were talking about the arithmetic operators. This is the equality operator that is used to check whether two things are equal or not. So everything you need to write is needs to be separated by a single space. Okay. So this is our condition, that is we need to check that if the value of a, whatever the value is stored in variable a, if it is divisible by 2 and if it is giving the remainder to us as 0, then we need to print that okay, this is even number. So the question is, how can we print that? For this we need to come to the next line and we need to type then. So then why we are typing? Because it is a part of the syntax of the if statement. Okay. Then after writing then, we need to provide a tab. We can just press the tab key from our keyboard because we are trying to provide indentation over here. Okay. Now indenting this line means that whatever line we are typing, it is a part of the if statement. Then what we are going to type is a simple message using this echo. And the message is whatever the value of a is, I want to type it as even, right? And this is the message. Then what we need to do is we need to end this if statement. That means we need to tell the shell script that my if statement has ended over here. So I can just write this fi. This fi, if you look closely, it is just the opposite of this if statement. So that's how these things work in the shell script, that is whatever statement you are writing, you need to provide its reciprocal or its opposite to make sure that okay, you are ending this statement over here. So this is one condition. This is how you can write one if statement, and it helps you to check that whether this condition is true or not, that is if a is even or not. I'm pretty sure that this will print a is even or 20 is even. Why? Because the condition is correct. Now if you want to check for the odd numbers, then how can you do that? How can you write the code for odd numbers? So we can simply just write another if statement. In this case, put a space in the square bracket. This time I'm going to check for the value of b, because this value I've taken as odd. So if b mod 2 is not equals to 0, which is exactly what I'm expecting it to give, because if we divide 13 by 2, we will not get 0, we will get 1 as the remainder. So in that case, I want the message to be echoed that b, the value of b is odd, and then I want to close the if statement with fi. So this is the whole script that you need to write for checking the whether the number is even or whether the number is odd. Here the operator we have used is the not equality operator, that is used to check means if the value is not equals to 0, then only it will give the output as true, otherwise it would give the output as false. So this is the not equality operator that we are going to use, and this is the whole script. Let us now just try to run it. So we can just press Ctrl X. You will be asked to save it, so yeah, you can save it. If you want to change the name, you can change it, otherwise just press enter key from your keyboard. Now if you want, you can just put a cat command here to just cross check the contents of the CNL file. So cnl.sh, and here are the contents. That's exactly the contents we wrote. Now let us just first use the chmod command to provide the execute permission for the owner of the file, that is the virtual user with which I am logged in with my Linux system. So you need to provide this execute permission for the cnl.sh file. Why? Because it is a shell script and we need to execute it. Now we just take a look at its permission. So you can see in cnl.sh we have this read, write and execute permissions as well, right? Now what we can do is we can just execute it with the help of this sh, that is cnl.sh, and you can press enter. Okay, so we are getting errors. Let's just check with the nano command once again that why we are getting these errors. Okay, so what I think here is we need to make some changes, and I will just make these changes real quick and then I will explain to you that what is happening over here. Okay, actually what is going on is it is this shell script that only works with some kind of a symbols, right? So you need to just make sure that you follow all these rules. Now I think we would be good to go. We can just save it, and then if we just try to execute it, yeah, now we are getting the output. So let's see what changes we have made by using this cat command once again. So if you see, we have made changes in this if condition over here and here. The first thing was inside these square brackets, if you are trying to evaluate any of the expressions like we did with the a mod 2, you need to always enclose it in double parentheses like this. Why we need to do that? Because we are trying to evaluate this expression first of all, and whenever we are trying to evaluate this expression, then we need this expression to be evaluated first and then any other stuff to take place. So that is why we have to include it in the parentheses to make sure that okay, this is the thing that must be executed first, and then this equality must be checked with 0. Now instead of the equality operator, we have used this EQ sign. That's because we are using the square brackets over here. This is a convention, that is, if you use the square brackets, you need to use this EQ sign to make sure that this thing works. Otherwise, if you are using the double equals, then you need to omit this square brackets and you need to replace it with something else. That's exactly the changes that we did in the next line as well. So what changes you need to incorporate if you want to use the if you want to omit the square brackets, we'll see in the next video. That's all for this video, and thanks for watching. In this video, we are going to see about the different relational operators available in the shell scripts. As we have already seen the conditional statements, that is the if statement, and understood that how they are executed, so it would be easier for us to understand the working of the relational operators in this video, right? So we would be working with the different relational operators. We would be writing a shell script in which the different relational operators would be used, and on the basis of the operators used, we would be using the if statements to determine whether the condition that we have given through the relational operators, whether those conditions are true or false. Okay, so let us first of all, using the nano editor, let us just create a file. So we need to write the nano editor, and the name of the file is opr.sh, that means for the operators.sh, and the first line that we are going to write is the shebang. So after writing the shebang, we need to just get a space of 2 to 3 lines, then we can begin writing our code. So we have taken two variables, a we have stored 10 and in b we have stored 20, right? Now the first relational operator is the equality operator, whose example we have seen in the previous video. The second one is the not equality, that is represented by a hyphen and ne. Its example also we have seen in the previous video. So I'm not going to reiterate their examples. If you just want to revise it, you can just go to the previous video and see it. In this video, we are going to focus on some more relational operators, such as the GT operator. Now GT is represented like this, and it is used to check. It is used to first of all take two values and compare them. So if the value that is provided on its left hand, if it is greater than the value provided on its right hand, then it gives us a true value. Otherwise, if it gives us the false value. Okay. So GT basically stands for greater than. It is used to check that whether the left hand side of the operand is greater than the right hand side or not. So this is the purpose for which it is used. Let's see how can we write it. So we need to write the if statement to make use of it. Then in this square brackets, you can simply write A GT B with a dollar like this. Okay. And if it is true, then that means we are checking that if the value of A is greater than B or not. So we know that it is not going to give us any output because it is not greater. So what we can write is, we can simply write that the value of B is greater. Okay. Then we can write Fi, and this just completes our shell script. Let's just save it and try to run it. So first of all, we need to just use the chmod command to provide execute permission for this opr.sh. Then we can just cross check whether the permission is granted or not using this file. Yeah, the permission is granted for the owner, that's the virtual user in my case, and then now I can execute this opr.sh. So we are not getting any output, the reason being because the condition was not true, so we were not able to go inside this if statement, right? This if statement will be executed only and only if this condition is true. Since this condition was false, so this if statement was not executed, and that's absolutely correct. Okay, so this is the GT operator. Let us just take a look at some other operators as well. Next we have is just the opposite of GT, that is the LT operator. So what we can do is we can just copy this by right clicking here and paste it, because this is the same piece of code that we need to repeat again and again, and we can just make some changes to it, right? Now instead of GT we have the LT operator, that is used for less than. And what is its purpose? It is used to check that if the value of the left hand operand is less than the value of the right hand operand. If the value of left hand operand is found to be less than the value of the right hand operand, then it returns true. That means in this case, this statement B is greater would be executed. We can just cross check it by saving it. Now we do not need to change the permissions in this case, we can simply execute it. And on execution we find that 20 is greater is printed, and that is absolutely correct because that is the output, right? Now if we want to just make sure of this thing, what we can do is we can just make some changes in the piece of code. Like we can make the value of A bigger than the value of B. So in this case we can write like A is greater, and here we can just reassign the values like A equals 10 and B equals 23 or 25 or something, anything. Okay, now what happens? We can execute it. So in this first condition we are getting 30 is greater, and in the second condition we are getting 25 is greater. So that's how the things work. That's how the greater than and the less than operator works, right? Next operator we have is greater than equals to. So what is this operator? It is used to again check for the left hand value. It checks that if the left hand value is either greater than the right hand value, or if it is equals than the right hand value, then it returns true to us, otherwise it returns false. So if you are working with this operator, you are automatically checked for two conditions, that is the equality condition as well as the greater than condition for the left hand operand. So let's see how it works. So what we can do is we can just use this operand for two conditions. First of all, we have taken the value of A as 30 and the value of B as 30 as well. So what we can do in this case is we can simply just paste whatever we have got. Now what we can do is we can just make some changes, that instead of this greater than, that is GT, we can write GE, that is greater than or equals to, right? And in the case we can just print that okay, A is greater or equal. That could be either of the cases, right? Then what we can do is we can just make the value of A greater, like by providing it with 40, and B we can just keep it as 30 as well. And then we can simply just paste the code, and if we are using this GE, that is greater than or equals to, then only we are getting that A is greater or equal. Right, so let's just see what happens when we execute it. So 30 is greater or equal and 40 is greater or equal, which is in either case the value of A. That is the usage of the greater than or the equality operator. That is, if the value is equal, that is in the case of 30, it gives us the true value, and if the value is greater or the left hand operand, that is in the case of 40, then also it gives us a true value. Similarly, instead of GT, we have something known as LT. So here also, instead of GE, we have LE, that is less than or equals to. So we can just make some changes here only, that if we are using LE instead of GE, so it is used to check that whether the left hand side operand is either less than or equal to the right hand operand. So in this case, the equality is here, so it will give us less than or equal. And here it is 40, so instead of 40, let us just reassign the value of A to 20. And here it will check that A is less than B. So in both the conditions, that is whether the values are equal or whether the value of left hand operand is less than the value of right hand operand, it will give us the true output. Right, so yeah, 30 is less or equal and 20 is actually less should be written over here instead of greater. So that's less or equal. So that's how the various relational operators work in shell script. If we just go and make a very simple change, that is, instead of this greater operator, instead of this GT, we can simply write this thing. Okay, and then we can just check it. So yeah, it's working, this first line. So if you want, you can use the symbols, but always with spaces. If you just omit these spaces, then it would return an error. Like, you cannot write something like this. So if you just write it, so then you can see that there is an error. So that's how you can work with the relational operators in shell script. In this video, we are going to see the and, or, and the not operators in shell script. So first of all, what are these operators? They are used when we try to just combine multiple conditions with one another. So three operators are used for this purpose, that is the and operator, or operator, and the not operator. These are the three operators used for this purpose, and each of these operators have a predefined set of rules according to which they work. The rules have been already laid off, and as per these rules only these operators work and just perform the operations based upon these rules. So these rules are stored for these operators. All these rules are stored in a table which is known as the truth table for these operators. Now we will take a look at the truth table for these operators. So this is what is a truth table. This is the truth table for the AND operator. If you look closely, then they are requiring at least two conditions to work upon. If there are more than two conditions, then also these operators could work. There is no issue, but at least two conditions would be required for the and the or operators to work. Okay, so let's see how it works. Here A means the first condition and B means the second condition. So what these conditions return, on the basis of that we can find out the result if we just use this AND operator. Okay, so this T means true and F means false. That is, if both the conditions, that is this T and T, both the conditions A and B, if they return true, In that case, we get the result as true, and if only one condition returns true, like in this case A is returning true while B is returning false, so we are getting the result as false. Similarly, if A is returning false or B is returning true, that is again only one condition is returning true, then again because of the AND operator we will get false as the result. And in case both the conditions evaluate to false, then the ultimate result is also going to be false. So in a single line, if both the conditions are true, in the case of the AND operator, then only you would be able to get true as the result. Otherwise, in all the other conditions, you will be getting false as the result. Next truth table we have is of the OR operator. So what does this truth table say? Here we have the different conditions, like in the AND operator also, the OR operator requires at least two conditions. Now, if we just take a closer look at its truth table, then we will find that if both the conditions are true, if A is true and B is true, then like the AND operator, OR operator is also returning the result as true. But in the case only a single condition is found to be true, like if only A is true, then also we are getting true as the result in the case of the OR operator. Similarly, if only the second condition is true and the first condition is false, then also we are getting true as the result in the case of the OR operator. The only case where we are getting false as the result in the OR operator is the last condition, that is in the case where both the conditions evaluate to false, then ultimately we are going to get the result as false in the case of OR operator as well. So this is how the truth table of the OR operator works. Next we have the NOT operator. So this NOT operator is slightly different from the AND operator and the OR operator. This NOT operator does not require two conditions. It can work upon a single condition very well. It is used for negation. That is, whatever the condition or whatever result you provide, it just reciprocates it. Like if you provide true to this NOT operator, it will just return false, and if you provide false to it, then it would just return true. So this is the usage of the NOT operator, that is, it is used to just reciprocate the conditions. Whatever Boolean expression you provide, it will just reciprocate it. Since these three operators work upon the Boolean values, either true or false, these are also known as the Boolean operators. So this is about their concept. Let us see their practical example. So we are again in our Linux. So let us just use this nano text editor to create a boolean.sh file, that is bool.sh. Now first of all, let us just create a shebang. Here inside this bool.sh, we are going to write a simple condition that is going to make use of the AND operator, that is going to make use of the OR operator, and that is going to make use of the NOT operator. So first of all, we were working about the AND operator, that is, it returns true only if both the conditions are true. So what we are going to do is we are going to take three variables, A initialized with 30, B initialized with 20, and C initialized with 10. Now in this case, what we are going to do is we are going to check that A is the greatest, is having the greatest value or not. So how can we do that? We can simply write the if statement, and we can write if $A is greater than $B. So that is our first condition, that if A is greater than B, then we want to check that if A is greater than C as well, because we have three operators, so we need to check that whether A is greater than B and whether A is greater than C. So these are the two conditions that we need to check, and that we can check in a single statement itself. So this is the first condition. Firstly, we have to check that whether A is greater than B or not. Then we need to check that whether A is greater than C or not. So these are the two things, A greater than B and A greater than C. These are the two conditions we need to check. Now these two conditions needs to be combined with an operator known as the AND operator. That's how you write AND in the shell script. That's a -A, and the AND operator would be written. Right. So that's how you can combine these two conditions by writing the AND operator. Why we are using AND operator? Because we need both of these conditions to be true for A to be the greatest number. And we know from the truth table of the AND operator that this is only possible with the AND operator. We get the correct output. Now we can simply write an echo statement. A and value of A we can just give is greatest, right? And then we can just close this if statement. Then we can just save it by pressing Ctrl X. It asks us to save it, so yeah, we can press yes and press enter. Now we need chmod to just update the permission for this boolean.sh file. We can just cross check it by using the lsl command on this boolean.sh file. So yeah, it is having the execute permission for the owner, and then we can just simply execute this file like this. So yeah, A with a value 30 is greatest. We got with the AND operator. Now suppose we just go again and we need to check whether A is greater than B or if A is greater than C. Now here what we are going to check, if either of the condition is true, that A could either be greater than B or could be greater than C. If any one of the conditions is true, I want the output. Okay, so in this case, if any one of the conditions is true, then we can simply use the OR operator with -o. So A value is greater than, simply you can write than B or C, because we are not sure whether it is greater than B or whether it is greater than C. So yeah, we can just make changes, we can execute it. So A with a value 30 is either greater than B or either greater than C. Why we were able to get the correct output for this? Because we use the OR operator. So we know from the truth table of the OR operator that if either one of the conditions are true, it is going to give us the correct output or the true as the output. So in this case, if you just cross check, this first condition was true and the second condition was false. Again, both the conditions were not true, still we get true as the output. So we were able to just get the this statement printed on our terminal screen. So that's how the AND operator and the OR operators work. A simple example of a NOT operator is you can just provide any value and it will simply negate it. So it's very simple. We have already seen its example in the case of non-equality operator, that is exclamation equal. So that was the not equal operator created with the help of this NOT operator only. So this video we are going to see the if condition. We are basically going to understand the if condition and more about the if condition, right? So basically in the previous videos where we covered the basics of the if condition, so this was our file that we created, cnl.sh. We took two numbers, that is an even number and an odd number, and we tried to check that whether the number is even or whether the number is odd, right? So we provided this on the basis of the fact that we already knew what the number was. But this is not always the case, because you can not always know that what is going to be the input, and on the basis of that you have to make your program that is a general program, that is no matter what the input is, it always gives the correct output. That is what we simply expect from a script or from a program to do, right? So here what we are going to do is we are going to make some changes in the basic structure of the program. We are going to understand some more concepts relating to the if conditions, and then we are going to just see that how can we make our program more generalized, right? So we need to make some changes into our CNL file. So let us just open it up in the nano text editor. Now here we are inside the nano text editor. What we are going to do first of all is we are going to just clear up this second if condition, right? Okay, and we do not need this B operator. what we are going to do is we are going to simply take variable a. We are going to initialize, firstly we have initialized its value is 20. Then we are going to check if it is even number or not. We know it is going to be even in this case, but this condition would only be true if the a operator or the a variable is even, and if it is odd, then this statement will not be executed. So what happens if this condition evaluates to false? Up till now, whenever we are writing the if statement, we are just handling the true part or the true condition. We are never working upon the false condition. So this is exactly what we are going to do in this video. We are going to try to handle the false condition as well. That is what happens, or what should we do if this condition gives us the false as the result. So what we can do is after this statement, this echo statement, or whatever you want to do when the condition becomes true, you can simply just write something known as else. So this else is again a part of if a statement, which is going to contain the lines that must be executed if the condition evaluates to false. So if the condition evaluates to false, what I want is I want to print the value of a with a message that it is odd. So in simple terms, our program becomes more generalized. What we get over here is, firstly we initialize a with a particular value, then we check it by dividing it with 2, and we check its remainder. If that remainder is equal to 0, we are giving a message that okay, a is even. And if the condition evaluates to false, that is, if this condition is false, then we are giving a message that a is odd. So let's just check it. So for that, we first need to close the file. So press Ctrl X to close it. You will be asked that whether you want to save the changes. You can press Y and then press enter. Now I can simply just execute this file. So I get 20 is even. That's absolutely correct. Now let's again just go to this nano editor and change the value of a from 20 to say 21. Now we are having the value of a as odd. Now after making these changes, let's see what happens. So yeah, 21 is odd, which is absolutely correct. This makes our program more generalized. So we can simply make our program more generalized with the help of the else statement. Now there is one more thing that you must need to know. That over here, what we are doing is we are simply taking the value, we are initializing the variable. But suppose we don't want to initialize the variable, we want the user to enter some value. So first of all, as soon as this user provides the command, that is the sh command, to execute this cnl.sh file, we want first of all a message to be given to the user that enter a number to check it is even or odd. To check even/odd. We want the user to enter this number, and whatever the number the user enters, we will check it for the user that whether that number is even or odd. Right. So we can simply give a message using this echo command, and then whatever the user enters, we want it to be stored in a variable called a. So we have written simply read a. This read is again a command that helps us to just read whatever input the user has given, right? So this is how it works. This makes the program even more generalized. Let's just save the changes and try to run it. Now if you press sh, firstly you will be prompted to enter a number to check whether it is even or odd. So I enter 32. I get 32 is even. Then again, I want to suppose check for another number. I can provide any other number like 97. Yeah, 97 is odd. So this is how you can make some generalized programs, taking the inputs from the user and providing them the corresponding output as per their inputs. Then this is using the if-else statement. Next set of statements that we have is if-else-if statements. So we can take a very simple example for this purpose. Right, let us just create a new file, if-el.sh. I'm not very good with naming files. So that's if-else-if statements. Let's start with a shebang here, and we can simply echo the user to enter a number, and we want to store it in variable a. Okay, or we can prompt the user to enter his age. So enter your age, and we are going to tell that if the user is greater than 18 years and if the user is greater than firstly we are going to check that if the user is greater than 10 years. If it is greater than 10 years, then we have two conditions, that the user could be like greater than 18 years, that means he's an adult. Otherwise, if he is between 10 to 18, then we would give like a teenager or an adolescent. And then if he is smaller than 10, we will give child as the output. So that's a simple thing. Okay, so enter your age. The first condition is that if whatever we have stored in age, so that's $a, is greater than or equal to, that's 10. In that case, we want to check some other things, that if the age is greater than or equal to 10, then we need to check that that we can provide another condition, or we can just write like if the age is less than equals to 10, then we want to echo simple child. Okay, so if the age of the person is less than or equal to 10, then we want the child to be returned. Else if, so we can write ALIF, that is else if the age of the person, so $a, is less than equal to 18, then we can simply write adolescent. We can echo adolescent. And else, that is if it is greater than 18, we want to echo adult, right? And then we can just close this if statement. So if the age is less than or equal to 10 years, then he's a child. If it is less than or equal to 18 years, then he's an adolescent. Or if it is greater than 18 years, then he's a adult, right? So let's just execute it. So here you can see that I just changed its execute permission, then I executed this. First I provided 12, so I get the answer as adolescent. Then I provided 8, then I get the answer as child, and then I provided the age as 39, so I get the answer as adult. So that's how you can work with the if-else statements and the if-else-if statements in the shell script. In this video, we are going to see the usage of the switch case statements in shell scripting. So up till now, we have seen the conditional statements, the if-else statements, the multiple if-else statements, the if-elif statements, etc. In this video, we are going to see the switch statements. So just like the if-else statements, the switch statements are also known as the conditional statements. Why? Because they help to evaluate the conditions, and whatever the condition returns, whatever the output is returned by the condition, according to that particular output, it helps us to take an action. So you must be wondering that it is the exact thing that what the if-else statements do, so why we bother learn about these switch statements? So the reason is that the if-else statements work only on one condition, and on the basis of of that particular condition, they check that whether that particular condition is true or false. So if you are going to work with some condition that could return multiple things rather than just if or else or true or false, then you need switch case statements. That is a condition that could return multiple outputs based upon its pre-requirements. Then you need to use the switch case statements. So this is exactly what we are going to see in this video, that how can we write a switch case statement. The example that we have taken is a very simple one. We want the user to enter a number between 1 to 7, and whatever the number the user enters, we will give its corresponding day. Like we will assign 1 to Monday, 2 to Tuesday, 3 to Wednesday, and so on. And whatever the number user enters, according to that we will give the user the message that okay, this is your day, or this is your day, or whatever it is. So that's a simple example we have taken for the switch case statements. Let us start with the syntax, or let's see that how can we practically write it. First of all, in the nano text editor, you need to write a file, create a file. Let's just name it as swi.sh. The first line is going to be our shebang. So yeah, now from here we can start writing our code or our script. So the first thing is going to be an echo message that please enter a number between 1 to 7. Because when we provide a message to the user, then only the user knows that okay, I need to write something, I need to provide a number between 1 to 7, right? Now this is what we are going to do, that is the number, and whatever the number the user enters, we want to store it somewhere, and that place is going to be a variable called n. So in n, the user entered number is stored. Now what we are going to do is we are going to actually use the switch case statement. So let's see how it's used. You need to write this case. Then what you need to write is inside this case you need to provide the parameter or the variable where the condition is stored or where the number is stored, on the basis of which you want to use the switch statement. Since in my case the variable name is n, so I'm going to simply write $n over here. Now after writing this $n, I need to put a space and write in. Then I need to specify the conditions. Now all these conditions are going to be indented, so you must specify a tab. Then what are the possible values of this n? So the possible values are from 1 till 7. So let us just write it for like 1 and close the parenthesis. This is the parenthesis, closing parenthesis you need to write. Then put a space and what you want to do if this condition matches. So if the user has entered 1, I want to print Monday, right? And then you need to specify within indentation these two semicolons, right? So these semicolons specify this end of the block, which means that Monday would be printed. Similarly for 2, you can just echo Tuesday like this, okay? And then again you need to indent it with 2 semicolons, okay? Then whatever conditions you want to provide, you can all provide them, and at the end you need to just close this case statement by writing its reverse form, that is ESAC. That's we learned in the if statement that in if we write fi, so in case we write ESAC. That's just the opposite of the word case. Now since we have written it, this script we have written only for 2 days just to check it. So let's just close it by pressing Ctrl X. You want to save it? Yeah. What's the name of the file? That's SWI. Let's just use the chmod to provide the execute permission for this particular file for the user or the owner. Then we can simply just execute this file. So you are prompted to enter a number. If we enter 2, we get Tuesday. Similarly, if we enter 1, we get Monday. That's absolutely correct. Now what I will do is I will make some changes in the file for all the 7 days, and I will just stop it for a second and I will meet you after making all the changes in the file. So now I have made the changes in the file. Let's just see the file with the help of the cat command, right? So this is the file. I have written it for all the 7 numbers 1 to 7. Let's just use the sh command and write and just check it. For 3 we are getting Wednesday, and so on. But what happens if we write like a number 9? Instead of 1 to 7 we write 9, so we get no output. But suppose we don't want this no output to be shown. We want the program to give a message to the user to tell the user that okay, you have made a mistake and that's why you are not getting any output. So how can we do that? Let's just see by just going to the nano editor. And here what we can do is we can just simply write the default case statement. That is the statement that would be executed in case all these conditions do not match. So this is like the super else statement. In the if condition, if the condition doesn't matches, we get the else statement. So if all these conditions don't match in the case statement, we get this else statement or the default case statement. And that is going to be like echo wrong entry. Okay, a simple wrong entry, right? And we can simply use this semicolon. Now let's just see our file. It's looking like this. Now let's just execute it with wrong entry 9. So we are getting wrong entry. Now let us just see one more thing. Suppose what you do is you just omit this semicolon in this Friday, okay, and rest all the things we are keeping same. So now if we just try to execute it and we provide f as the output, so we are getting an error. So whenever you are omitting or thinking of omitting this semicolon, then you must remember that if you omit it, you will get an error. So it is a syntax that you should work with and you should always remember to put these semicolons, okay? Otherwise it may be an unfavorable outcome. So that's how the switch statements work. That is how you can just handle multiple conditions using the switch statements. If you want, you can just check it as many times as you want. It is always going to give you the correct output, right? So this is how the switch statement works. I hope you all have understood about it. In this video we covered everything that we need to know about the switch statements. If you want to practice more about them, you can just take random examples. One example I can tell you is like you can accept the numbers from the user, and from 1 to 12 you can accept the threshold, and between that 1 to 12 you can assign the months to them, like 1 for January, 2 for February, 3 for March, 4 for April, and so on. So this is a practice example which you can practice for yourself. So that's all for this video. In the next video we are going to learn more about the shell scripts, that how they work, what is their purpose, and everything. In this video we are going to take a look at the loops in shell script. So what is a loop? A loop is basically a programming concept that helps us to execute the same set of statements again and again until the provided condition evaluates to false. Okay, so basically if you want to repeat the same process or the same steps again and again, then instead of writing the code multiple times, what you can do is you can just write a simple loop and you would be able to just automate the process of repeating by using just a few lines of code. So that's the basic concept behind loops, and they're very useful whenever we are trying to work with long programs. So let's see that how can we create loops in shell script. So first of all, we have 4 types of loops in shell script. Out of these 4, the most used loop is the for loop. It is the most famous loop in each and every programming language and also in the shell scripts. So we are going to start our discussion of loops with the help of the for loop. Let us just take a simple example. Suppose you want to print numbers from 1 to 10, and you would just want to like write the number is 1, the number is 2, the number is 3, and so on. The number is the message, and then 1 2 3 to 10 you want to print. So this is a task that is requiring the same thing, the same printing message to be written again and again. One approach could be that you could write 10 echo statements and you would be able to get the output. But if you have the task a little bigger, that you need to write the numbers between 1 to 1000, then you need to write the echo statements 1000 times. If you go with your approach of just writing 10 echo statements, then in that case you need to write 1000 echo statements. So that could be a little problematic. But if you are given the task to write like 10,000 numbers from 1 till 10,000, then that could possess a problem. So we have the loops with us, which helps us to do that exact thing. Let's see how we can work with loops. So for that we need to just use the nano editor to create a file. Let's just create loops.sh and start the file as usual with our shebang. So that's the shebang, and let us just write a loop in which we are printing the numbers from 1 to 10. So there are different approaches which you could follow. The first approach is that you can write the for loop. This is the syntax, so you need to just follow it exactly. Then you need to provide a variable, that is say I. Then you need to provide, using the in operator, the range of the variable. So here you can specify the different numbers. Since we are trying from 1 to 10, so you can simply write 1 space 2 space 3 space 4 space 5. All the numbers you want with a space, you can write them space separated numbers. Then after writing them, you can just provide this do, and inside this do you need to indent it. You can write the message echo, the number is that's $i. Okay, and then you need to close this for loop by writing this word done. So let's just close it using Ctrl X. Let's just save it and save it. Now we will be using, you guessed it right, chmod to just execute the permission, and we can now use sh command to execute this loops.sh file. So yeah, we are getting the correct output, that is number is 1 to 10. But you must be wondering what good we got from this script, because ultimately we had to print these 10 numbers, we had to type those 10 numbers. The only good we got was that we didn't need to write this echo statement 10 times and the number of the lines were less. So this is one approach of how you can just work with the numbers. The other approach, that if you have large numbers, then how can you go with it, is like this. You can simply, instead of writing these numbers, what you can do is you can just use these braces, these curly braces. You can write the first number, put 2 dots, and then you can write the last number, that is 1 till 10. If you want, you can provide 100, 1000, whatever you want. Let's see how it works. So yeah, 1 to 10 is what we've got. Okay, so why did we got this? That's because let's just go here. Actually, what we need to do is we need to put spaces here, I think. Okay, so this is another thing. Actually, this is not the numbers through which you got. You can just separate different things. Like we provided a brace, then we separated it with a space and then a second thing, and then a brace and then a second thing. Okay, so basically what happens is, let us just keep the numbers aside for a time, and we can just provide different kinds of outputs. Like we provide the numerical output 8 into 9 or 8 plus 9 or 8 plus 9, yeah, and we can just provide some kind of a string message like hello, or we could provide something else, whatever it is. Whatever things we separate with spaces would be printed in loops like this. So you do not need to worry that what we are providing, everything that you provide would be printed as it is. Okay, so if you are looking for the output of the expressions, what you can do is you can just provide it with a space like this. Okay, so that's the different expressions that we got. Right, now if we come back to our topic, that is how can you print the numbers, then what you can do is you can just use a different kind of a for loop. That is, you can write the for keyword, put a space, and then you need to write everything between these double parentheses. Okay, suppose we want I to be our variable, to be a loop variable, and we want it to start from 1 and it needs to be executed till the number 10, right? So then you want to increase its value one at a time. So that's what is going to do the trick. So you can specify in the double parentheses like this. You do not need to worry about writing the same thing again and again. Okay, so we are getting some error. Let's see where the error is. So the reason why these statements were not working before was because they were stored in a shell script file, and due to which the error might have occurred. But actually there is a way through which you can work with for loops in this case. Like if you just write it like this and directly in the terminal, you can just press enter, then you can specify do whatever you want. You can just echo it. I want to just echo the value of I, and then I can simply write done. Then what happens is the correct output is this, that is from 1 to 10 I have got all the numbers. So this braces thing is also a way through which you can work with the different ranges of numbers given to you. Another way we discussed earlier was this double parentheses. So yeah, this is also a valid way. It was not working in the shell script because of some error due to the script file, but actually this is a way through which you can do that, and that is like this. You need to specify all these things. Then since we are inside the loop, so we are getting this kind of a symbol, that is whatever code we write would be inside the loop. So we need to start the loop by using do, and then using this echo statement we can just print its value and then done. Now when we press enter, we are able to get all the numbers from 1 till 10. So that's how the for loops work. That's how you can just write the different types of methods of a for loop. Now there is one more method through which you can iterate with the numbers, and that is through sequence. That is known as SEQ, or the sequence. Let's see that how can we work with the sequence. It is actually an outdated method, but still if you want to learn it, you can learn it. Like for I in, you can specify the sequence with a dollar symbol. With a dollar in the single parentheses, you can specify the sequence. So you will get it like this. SEQ, you need to specify 1, that is the starting condition. Then suppose you need to find provide the step value, that is how much difference is going to make. So it's going to make a difference of 1, and what is the ending value? So that's going to be 10, which means I want the numbers from 1 till 10 all separated by a 1. Then simple do echo the value of I and done. So yeah, 1 to 10 is here. Now if you remember, in the previous video we created a loops.sh file in the nano editor, and some of the syntaxes of the for loops that were simple and that worked in the terminal were not working in our loops.sh file. So I have again tested all of them. So still some of them are working, not all of them are working. If you take a look at this SEQ that we saw in the previous video, so this SEQ is working. I just executed this loops.sh file, so I'm getting 1 to 10 output, and this is the current contents of my loops.sh file, which is the SEQ thing I have got in my loops.sh file. If I just show you to execute again, then again it's working. So there are only some things or some syntaxes that are working whenever we are going inside our shell script or we are creating a .sh file, not all. So if you are trying to work with the for loop, either you should go with these methods only, or what you can do is you can simply type it on the terminal itself, right? Now there is some more things that we need to just learn before continuing with our loops. First of all is that how can you increase the step count? So if you remember that in sequence we had the step count, so we just used to write it like this, that for I in, and with this dollar we specified this sequence SEQ and the starting value, then we provided the step count. So if we just do the step count as 2 and suppose we provide 19, so what will it do? It will automatically just print like 1, 3, 5, etc. The step count of 2 means that it would just give us the next number after skipping the 2 numbers, right? So if you want all the odd numbers between 1 to 19, that's how you can just work with. So what you can do is you can simply write do and you can echo the numbers. So that's going to be I, and you can provide it with done. So yeah, 1, 3, 5, 7, 9 and so on. All the odd numbers have been listed over here. Next, there is another method through which we can provide the step count value in the for loop, and that is through this method. Like we provided the braces, if you remember. So in the braces we provided the starting value and the ending value. Suppose we now provide the starting value, put 2 dots, provide the ending value, say 20, and then with the help of 2 dots you can specify the step value. By default it assumes that the step value you are going to take is 1, but if you have specified anything explicitly, then that value becomes the step value, and in this case 2 is going to be the step value. So when we execute this statement or this loop, then what will happen is from 0 to 20 all the even numbers will be printed. We can simply write like do, we can echo the value of I, and then we can write done. So here it is 0, 2, 4, 6, 8 and up till 20 we are getting all the numbers. So that's another method of specifying the step values if you want any other step value instead of 1. Now there is one concept known as the infinite loop. So what is an infinite loop? If you see the loop examples, then what we are getting is a starting value and the ending value, which means we are providing a range in which the loop must work. It should start from the starting value and should go on till the ending value, right? So what happens if we just forget to specify the ending condition, or if we just forget to specify some updation condition or whatever it is, right? Then in that case the loop that happens is known as the infinite loop. It just runs for the eternity and it runs until and unless it consumes all of the resources of the system and makes the system hang. So this is a faulty thing to happen with this process, or with an infinite loop. A lot of harm could be done to your computer, like copying a file infinite times on your PC may exhaust all its resources, so it is a harmful thing. So you must know that how can you just stop an infinite loop if it has occurred in Linux. So for stopping the infinite loop, we first must create an infinite loop. So let's see how to create the infinite loop. So since we are working with a for loop, that is the reason we are only using this for keyword to create an infinite loop. And a very simple example is to create a for loop with these double parentheses. What you can do is you can simply just write this by providing a space and put a semicolon. Again put a space, put a semicolon, and again put a space. So this is the syntax of the infinite loop. You have not provided any starting condition, you have not provided any ending condition, you have not provided any updation condition. These three things you have omitted, and that is why this loop is going to run till eternity. So when you press enter, you are supposed to write the syntax or whatever the body of the loop is going to contain. So my loop body is going to simply give a message that you are in an infinite loop. Right, so it's infinite loop. Okay, and then you can click on done. Now as soon as you press enter, you can see this thing infinite loop is going on and on and on, and it is taking up a lot of resources. It's not stopping anywhere. So the question is, how can you stop the infinite loop? You have a shortcut called Control C. As soon as I provided this Control C, you can see this kind of a sign appeared over here and our infinite loop stopped. You can just keep on scrolling. You see, I'm just scrolling it like this. And you see, this is the number of times our infinite loop has run. Okay. So that's how you can stop the infinite loop using Control C. Okay, so that was about the infinite loop. Now we have an interesting thing in Linux, an interesting concept in Linux, and that concept is known as the file test operators. Suppose if we just use ls, so we have all these files. Okay, all these files are present in the current directory. And if we just use lsl, so yeah, these files are having these kinds of permissions, right? Suppose you want to just check for a particular file that if the file has read permission or not, then how can you check it using the file test operators? That's exactly what we are going to see. So for this purpose, you can simply just create a variable called file, and in this you can just store any file. Say bool.sh is what I'm going to store, right? Okay, so you can either use the dollar symbol, or what you can do is, yeah, it's creating some problem. You can just omit the spaces. So this is a thing that you must make sure every time you have. Okay, if it is causing a problem, you can simply just go to editor and create a file.sh. Let's just meet after writing the code. So this is the code that I have written. That is, in this file I have stored a file called bool.sh, and I'm going to check that whether this particular file is having the read permissions or not. So this thing called or the switch called -r is used exactly for this purpose, which is used to check that whether a file is having a read permission or not, right? So this is what I have created as code. Let us just exit out of it and try to read the contents of this file.sh. So these are the contents, right? Now we are talking about a file called bool.sh. If we just try to see that what permissions this file bool.sh is having, so it is not having the read permissions. Okay, now if we just execute this script, that is the script stored in file.sh, then what happens? So this is the script. We get the answer as unread, which is absolutely correct, because if the file didn't have the read permissions, we wanted unread to be shown, and as you can see, this file bool.sh is not having the read permissions. That is why we are getting the output as unread. So that's how these different file test operators work. They help us to check the permissions for the files and many more. So that's all for this video, and thanks for watching. If you remember, in the previous video, we learned on how to use and execute the for loops. So in this video we are going to discuss about a different type of loop that are available in shell script, and this is known as the while loop. So the concept of while loop is same as just of a for loop, and that is it is used to repeatedly execute the same script again and again. So since while loop is also a loop, so it also requires some condition on which it can act upon, and the concept of the while loop is that it enables us to execute a set of commands repeatedly until the condition becomes false. And when you need a while loop, it is usually used when we need to manipulate the value of a variable repeatedly, right? So basically what happens is, while loop takes a condition, and while the condition is true, it executes itself, and as soon as the condition becomes false, the while loop stops its execution. Now you must be wondering that why do we use for loop? So for loop is used when you know exactly that how many times you need to execute your statements, right? When you know the starting condition, when you know the ending condition, when you know everything. But while loop is used when you know that okay, this is our condition and we need to execute the statements while this condition is true. So this is the difference between using these two loops, the for loop and the while loop. In this video we will see with the help of a practical example that how can we write a while loop. So first of all, I am going to show you a simple example. Then I will show you that how can you actually create an infinite loop out of a while loop. If you remember, we also saw creating an infinite loop with the for loop condition as well. So in the while loop also we will see the infinite loop. So let us just create a simple text file in the nano text editor. So we know the method for it. You need to call the word nano and then give the name of the file. So wl.sh, wl stands for while loop, and .sh is the extension because it is going to be a shell script. Then press enter. The first line is going to be our shebang, right? Now you can start the execution of your while loop. So what I'm going to do is I'm going to just print the numbers from 1 to 10 using while loop. Okay, that's a very simple thing that I'm trying to do with the help of while loop. So I'm just going to take a variable n and initialize it with 1. Then this is an important part because I will be telling you about the syntax of while loop or how can you write a while loop. So first of all, you need to write the keyword while, put a space, and then you need to start with a square bracket. Again you need to put a space. Now what is our condition? Our condition is that we want the numbers to be printed from 1 to 10. So in this condition part, we need to check that whether the value of n is equals to 10 or not. If it is equals to 10, then we want to stop the execution of the loop. Otherwise, if the value of n is less than 10, then in that case we need to continue the execution. That means we need to use the operator that is LE, that is less than or equal to. So here what we can do is we can simply write the value of n, because the value of n is what we need to compare, right? So $n, put a space, put a hyphen, less than equal to what number? With 10, because that is what our condition is. We want to print the numbers till 10. If we wanted to print the numbers till 5, then instead of 10 here would be 5 written, right? Then after putting a space, you can just close this square bracket. Now after closing this square bracket, this is whole condition of the while loop. Then what you can do is you can simply just tell shell script that okay, you can just begin the body of loop by writing this do keyword. Then in the very next line, using a very simple echo statement, you can just echo or print the value of variable n. Right. Now After printing the value of variable n, you need to update it as well. Like when you just execute it for the first time, the value of n is 1 because you have initialized it with 1, right? So 1 would be printed, but for the next execution or the next iteration of the loop, you want n's value to be updated to 2. So in that case, you need to provide this updation statement as well. So there are two ways through which you can update the values of the variables and store those updated values in the variable. The one is using the expr command, which we have already seen. If you don't want to use the expr command, or you are looking for a kind of a simpler method, then what you can do is you need to write n or whatever variable where you want to store your updated value. Okay, then without any spaces you need to write equal sign, and then without any spaces you need to write this dollar symbol. Then after this, with no spaces again, you need to write these 4 parentheses, that is 2 opening parentheses and 2 closing parentheses, and inside them you can simply write n plus 1. So this is a way through which you can update the value of the variable. The other one is through the expr command. If you're wondering how can you write the expr command, so that's how you write it. You can simply write like expr, then you need to put a space and a $n plus 1, like this. But we are not interested in writing the expr command. Why? Because we have got this simpler method. This is more simple because all you need to remember is that you do not need to provide any spaces, and simply you need to write these 2 opening parentheses and 2 closing parentheses. Now that's all we need to do in the while loop to print numbers from 1 to 10. So we can just finish this while loop by pressing or by providing this done statement. Now let's just save this file, that is wl.sh. Now what is the drill? You all know we need to provide the execute permission for this wl.sh, and then we would be able to execute it, right? So yeah, you can see we have got the numbers from 1 to 10. Now if you want, you can also execute this script directly on the terminal itself. You can simply just write the while loop, and this script would be executed directly on the terminal as well. Like you can simply write while, like this. Why I have kept this? Because I want to create an infinite loop. If you want to create an infinite loop out of while loop, you need to skip the condition part, and in order to skip the condition part, you can simply just provide it with a colon, so that while loop doesn't ask you for a condition. Then you can see we are getting this kind of a symbol, which means that okay, now we are inside the body of while loop. That is, whatever statements we provide, either it is going to be the do or the done statement, or something that is related to the body of the while loop, right? So the first statement we know is going to be the do statement. The next statement is going to be an echo one, and it's going to echo infinite while loop. Then the very next line is going to be a done, and then you can see it's going on and on and on. Now you know how to stop it by pressing Ctrl C from your keyboard, and you will see that the infinite loop has stopped its execution. Now if I just scroll it above, you can see how many times it has been executed, right? So this is how you can create a while loop, an infinite while loop actually, in the shell script. Now if you just press this up arrow key, you will see this kind of a statement. All the statements that we wrote that are separated by a semicolon. That's actually how you can write multiple statements in the shell script. All the statements could be just separated with a semicolon, and after separating them with the semicolon, you can just bring all the statements in one line only. You do not need to write them again and again in different lines. Hello everyone, welcome back to the Linux tutorials. These tutorials are brought to you by Zeedup Technologies and Services. In this video, we are going to see another type of loop available in the shell script, and this loop is known as the until loop or until command. So up till now you have seen the for loop and the while loop, and if you want to continue programming in shell script, or if you want to continue to write scripts, then learning two loops is more than sufficient. But since this until command or until loop is also a concept in shell script, so it is advisable to just have a knowledge about it. Okay, so what is the until loop? It is also a loop that helps us to just execute the conditions multiple times. So why do we get it? Well, if we talk about while loop, so it is perfect for a situation when we want to execute the commands while the condition is true, right? And for loop is perfect for the situations when you know exactly how many times you want to execute these statements. Now there are some conditions or there are some situations where we need to execute a set of commands until a condition is true. So this is where this until loop or this until command comes into play, where we get the option to execute the commands until the condition is true. So whatever condition we provide, if its resulting value is false, then only the given statements are executed. Otherwise, if the value of the given condition is true, then in that case the statements will not be executed and the loop will end. So the while loop, whatever the while loop does, the until loop is completely opposite of it, right? So let us take an example and try to learn that how can we actually execute the statements using the until statement or the until loop. Okay, so first of all we need to create a file for that purpose. So let us just go to our nano text editor, and until loop, that is ul.sh, is going to be the name of my file. The first thing we are going to create is the shebang. So that is the shebang, and now we can begin with our until loop. So what is we want to do? We are going to take the same example we have been taking up till now, that is we are going to print the numbers from 1 to 10, but this time using the until loop. So how can you do that? First of all, you need to take a variable, say a, and initialize it with 1. Then from this line onwards we are going to start with our until loop. So how can you write an until loop? It is very similar to writing a while loop, but instead of while, here the keyword that you need to provide is until. Then you need to put a space, and within these square brackets you can write something, okay, some stuff. Now what is this thing going to be? First of all, you need to provide a condition. So the condition is that I want to print the numbers from 1 to 10. The condition must be that a should be less than 10 or a should be equal to 10. As soon as a becomes more than 10, I don't want any printing to happen. I just want 10 lines to be printed, that is 1, 2, 3 up till 10, right? So this is going to be my condition, that is a, and I'm going to use this less than equals to 10, right? Now make sure that only one spaces are between each and everything. You can just cross check it, right? Then you can just come to the next line and write this do statement, and inside this do there are going to be two statements. The first one is that we are going to echo or print the value of our variable a, and the second one is going to be the updation part, because we need to update the value of a after printing the value. Like we have printed 1, so we want the value of a to be updated to 2, then to 3, then to 4, and so on. So you can write just like a equals and with a dollar and two opening parenthesis, two closing parenthesis. You can simply write a plus 1 like this, okay. and then you can do you can just print the done statement, because that's exactly what we wanted to do. So this is a simple 2-3 lines of code that you can write, and that's how it would be printed, right? Now let's just save it. Okay, now we know the drill. That is, using the chmod command, we need to update the permissions for the owner. By this, we are going to provide the execute permissions to the owner, so that as an owner of the file, we are able to execute the script that is written inside it. Then we can simply use the sh command to execute the file. Now what happens? We are not getting any output. Why? Let's just go back to our file. Here you see in this until, if you just remember the concept that I told you was that if the condition that is given is false, then the statements will be executed, and if the given condition is true, then the statements will not be executed, right? So if we check this condition is true. That is why these statements are not executing. So to make this true condition as false, if you remember, we had an operator, and that operator was known as the not operator. It uses itself to just negate the value. Like if it is true, it just converts it to false, and if it is false, it converts it to true. So that's exactly what we want, right? So what we can do is we can simply just write the not operator over here, and then our loop will work fine. So the not operator is represented by this exclamation mark or this exclamation sign, and then you can just make sure that there is one space gap between everything that is written and which you are supposed to write separately. Like you can see that not operator is separate, this a value is separate, everything like this. Okay, so this is how you write the until loop. Now we can again make some changes or just save the changes into our file, and now if we execute our ul.sh, then you can see we are getting the output like this from 1 to 10. So this is how you can just work with the until loop. That's how this until loop works, right? Now suppose this was a very simple example of the until loop. So this is an important thing that you must remember, that whenever you are using until loop, what is a simple trick? You can simply just write the original condition that you want to execute, and then you can simply just provide a not operator. Or what you can do, there is another way. If you don't want to use this not operator, what you can do, we can just omit this not operator, right? And instead of less than, what we can do is write this greater than or equals to 10. Now what happens is the condition is false, right? And this will also do the trick. Either you can just write a not operator, or you can just reverse the symbol, right? Like if you're expecting it to print up till 10, you can just write greater than 10 instead of less than. And if you're expecting it to go for greater than, you can simply write less than. Okay, so let's just see how it works. Let's just save it, and yeah, ul.sh, and execute it. So then also you can see it's working, but in this case we are not getting the output as 10. Why? Because we used this equals symbol. So that's why the condition for 10 becomes true, and that's why for the 10th value the statements are not executed. So you can simply write GT. That is, if it is only greater than 10, then only we want the statements to stop executing, right? So now we can just save it and execute it once again. So yeah, 1 to 10, all the values are printed. So this is the usage of until loop. It is a bit confusing, but if you are able to understand it once, then you will be able to work with it very easily, because it is a very simple loop. Okay, so I hope you all have understood about until loop, and that's all you need to know about this loop. So in this video we are going to see the select loop in shells. So select basically is a combination of loop and the case statement that we already saw. So the case statements that we work upon were like giving us the different cases in which we could work with, where we could just select the different values from the given statements. So what we are going to do is we can just use the select loop along with the case statements, and we can just select the different options available to us. So basically, what does the select loop does? It provides a menu to us, right? And from that menu there are these different options available from which we can just select those options. So it is particularly useful when there is a list of choices available, and as per the user choice the things could work. Like if the user chooses something, then he could get some other output. If he could get or choose some other thing, then he gets some other output, and that's exactly how the select loop works. So since we know already that using the case statements we could handle multiple conditions or multiple choices, so we are going to see the select statement along with the case statements in this video. But it is not mandatory that all the time the select statements must be combined with the case statements. You can combine it with any statement that you want. So let us start. What I'm going to do is I'm going to take 2-3 names of drinks, and that menu would be shown to the user, and as per the user choice he is going to get that whether that drink will be served as hot or whether as cold, right? So let's see that how can we work with it. So I'm just going to write this shell script on the terminal only, right? So let us just write begin our script. So it is going to be the select statement like this, put a space, and then you need to create a variable, right? So since it is drink, so I'm just going to create a simple D. Then you need to provide the in statement, and then you need to provide the space separated values of the different drinks that are going to be in the menu. So whatever values you provided here with space separation, they all would be a part of menu and it would be shown to the user. So the user would be able to make a selection out of these different values only. Okay, so be careful while providing these values. So I'm going to provide tea, coffee, water, and juice. Okay, then you can press enter. Now you can see we have got this kind of a symbol, which means that we're inside the body of the select loop. Now we know to begin any loop we need to provide this do keyword. So yeah, here also we have provided the do keyword. Now what happens is inside this loop body we can very easily provide the case statements. So let's just write the case statements. If you remember from our previous discussions that how the case statements are written, then it would be easier for you to follow along. Otherwise I will explain you. So simply you can write the word case, and then you need to refer to the particular variable where the options are stored or where the menu is stored. So it is in D. So we need to call that. So case $D, and you can write in. Then you can just go to the next line and you can specify the options like tea. If the user has chosen tea, then you want to echo hot because tea is served hot. Then you can just use these double semicolons, and similarly you can just write it for all of the cases like coffee. It could be hot and cold both, so I'm just going to echo hot / cold, and then this double semicolon. Next we have water. So water, it could also be both hot or cold, so you can simply write hot / cold, right? And then the semicolons. Then the last but not the least we have juice, which is presumed to be served cold. then the semicolons. And now if you remember from case statement, we have asterisk option, which means the default case. If none of the cases matches, then we can go with it. So let's just provide a default one as well, and it's going to be the wrong choice or any message that you want to give to the user. And then again you can just close them, and now you need to close the case statements first. So if you remember, we have ESAC to be written to close the case statements, and then the select loop needs to be closed so that you can provide the done statement. And as soon as I press enter, you see I have got this tea, coffee, water and juice with these numbers automatically assigned to them, 1, 2, 3 and 4. So if I just select like 2, what I get is hot/cold. Why? Because I selected coffee and I provided coffee to be either hot or cold. Now if you want, you can provide any other number like 1, so that's for tea, that's hot, then 3 for water and 4 for juice. Now these are all the valid options. What happens if you just provide an invalid option, say 5? So I get a wrong choice. Why? Because of the fact that I used this asterisk symbol to specify that if the user goes out of any choice, or if the user provides like any kind of a different number that is not present in our menu, then we are going to get a message of wrong choice. So that's how it works. That's how you can execute these statements. Now what happens is, suppose you are repeatedly going on giving numbers and it's just handling them like this. Okay. Now what happens is, after a few choices, your menu will vanish. Now if you want to bring the menu back again, what you can do is simply press enter without writing any number. This hash and question mark where it is shown, you can simply press enter and your menu would be there again. Now again you can make selections over it. Now how can you just skip it and come back to your dollar prompt? Well, there are two ways for it. One is either you can just provide a jumping statement inside your case statements, but since we have not learnt about the jumping statements, so we have not provided the jumping statements. So what you can do is you can simply press Ctrl+C from your keyboard to jump out of the loop, to jump out of the select loop, and then you can see you are back in your dollar prompt. So that's how the things works, right? Now there is one more interesting thing. I have just cleared the terminal, but if I just go to this particular statement, I can just go back to it using my arrow keys and I execute it again. Now you can see that I am getting this enter a number over here. So why is that? Before, if you remember, we got that hash symbol and a question mark, right? But now we are getting this enter a number. How? So actually we can just press a number and the output is same. We can just come out of our loop back into our default prompt. That is actually because of a variable that is known as the environment variable. So environment variables have predefined meanings in the shell script, and they are used for different purposes. Like PS3 is an environment variable which is used to just show us a message. Okay, so here whatever message is displayed, it is stored in a variable called PS3. So if you want to change this message, or if you want to give a custom message, you can simply just change that particular variable. So you can just see, this is the command that I use to just change this variable from nothing to enter a number. Now what happens is, whenever I just get this menu, I get enter a number, which is more user friendly. If you want, you can just put spaces etc. over here to make it more readable, to make it more interesting for the user to interact with. Then you can press enter. And since we are working with the terminal directly, so we need to again use the select statement. So then you can see it's working like this. So that's all for the select loop. that you need to know in shell script, and thanks for watching.